Okay, what if I told you that reality as you know it is basically shattered? Seriously, just take a second and imagine everything you have ever seen in your entire life. I'm talking every mountain, every ocean, every star in the night sky, every planet, every glowing galaxy out there in the cosmos. Picture all of it. Now realize that everything I just listed, and yeah, even you yourself, makes up just a tiny, microscopic fraction of actual reality.
Let's really dive into this because the numbers here are absolutely staggering. That little 5% sliver of ordinary matter, that is literally everything we know, see, and interact with. The remaining 95% of our universe is entirely invisible. It's made up of stuff we cannot see, we cannot touch, and honestly, we don't fully understand. We are quite literally floating in a vast, unseen ocean made up of 27% dark matter and a whopping 68% dark energy.
So this brings us to the 95% mystery, the invisible forces that are actually shaping reality.
Let's kick off this explainer with suspect number 1 in our cosmic detective story, dark matter, or as it's often called, the cosmic skeleton.
Now, dark matter is incredibly weird because it's defined almost entirely by what it isn't. It doesn't emit light, it doesn't reflect light, it doesn't absorb light. It is completely invisible to every single type of telescope we have that looks for electromagnetic radiation. So you might be wondering, how do we even know this phantom substance is out there? Well, the only way we know it exists is because of its massive gravitational pull. It acts like this invisible, heavy skeleton that literally holds galaxies together.
And this is absolutely crucial to understand because without this invisible skeleton, things just wouldn't work. Picture swinging a bucket filled with water around on a rope. If you spin it way too fast, what happens? The water flies right out, right? Well, the exact same thing should be happening inside spinning galaxies. The stars far from the center are moving so rapidly that, according to the standard laws of physics and the mass we can actually see, they should be flung violently out into deep space. But they aren't. What actually happens is that galaxies are held tightly together. There's this massive, unseen weight generating enough gravity to keep those fast-moving stars safely locked in their orbits.
Scientists have built a rock-solid case for this invisible mass, mainly relying on 3 massive clues. First, as we just talked about, galaxy rotation speeds. Stars are just orbiting way too fast for the amount of visible stuff we can see. Second is gravitational lensing. So Albert Einstein taught us that massive objects bend the very fabric of space, and therefore they bend light. Astronomers constantly look out into space and see light bending wildly around completely empty regions. Something invisible but incredibly heavy is sitting right there providing that gravity. And third, we have this smoking gun, the bullet cluster collision. Basically, 2 massive galaxy clusters smashed into each other. Scientists watch the ordinary visible matter, like gas and dust, slam together and slow down. But the vast majority of the gravitational mass, it passed straight through like a ghost, completely unaffected by the crash. This proves, without a doubt, that dark matter behaves entirely differently from the normal matter making up you and me.
Which leads us to the hunt for these dark particles. Let's look at the prime suspects.
We know it's out there, but what actually is it? To figure that out, we are throwing the most advanced machinery humanity has ever built at the problem. We're talking powerful particle accelerators like CERN in Europe, massive underground detectors buried deep in the Earth to block out background noise, and even the James Webb Space Telescope staring back at the dawn of time. Through all this, scientists have narrowed it down to a few leading ideas on our cosmic suspect board. First up, WIMPs. That stands for Weakly Interacting Massive Particles. These are theoretical heavyweights that barely interact with normal matter at all. Next in line are axions. These are incredibly tiny hypothetical particles that would be super light but extremely abundant. And finally, sterile neutrinos, which are basically an undiscovered phantom version of the already ghostly neutrino particles we know exist. But here is the crazy part. Despite massive international efforts and billions of dollars in research, none of these particles have been directly detected yet. The true identity of dark matter remains totally at large.
Just when you think the universe couldn't get any weirder, we have to talk about dark energy, the unknown force.
So we're moving from the pulling force of dark matter to its ultimate antagonist. And I want to ask you this question, one that scientists were absolutely certain they had the answer to for decades. Since the Big Bang, the universe has been expanding. But because all the matter in the universe has gravity, and gravity pulls things together, is gravity slowly slowing the universe's expansion down, like putting on the brakes?
For a really long time, everyone just assumed the answer was yes. But in 1998, astronomers were looking at distant supernovas and discovered a shocking twist. The answer is no. The universe is not slowing down. In fact, it is expanding faster and faster and faster.
Something out there is aggressively pushing galaxies apart, literally accelerating the expansion of space itself.
And that mysterious repelling force is dark energy. Remember that 68% figure from earlier? Dark energy doesn't pull like dark matter does, it pushes. And it makes up a staggering 68% of the entire universe. It acts as a relentless, invisible engine driving the fabric of space apart at an ever-accelerating rate. It is the dominant force in reality, and we have absolutely no clue what it is.
So, what does this all mean for us? Let's look at the fate of the cosmos. Are we headed for a cold, dark future?
This cosmic tug-of-war isn't just some abstract physics puzzle. It literally determines the ultimate fate of the cosmos. Right now, in the present day, we're in an era of accelerating expansion. Dark energy is winning the tug-of-war. If this continues into the far future, galaxies are going to be pushed so far apart that the night sky will eventually go entirely black. Stars will age, they'll burn out, and the gas needed to form new stars will be stretched way too thin. Ultimately, this trajectory leads us to the end, a universe that is vast, cold, dark, and almost entirely empty. But there's an even more intense, highly speculative theory called the Big Rip. If dark energy actually gets stronger over time, the expansion will become so incredibly violent that it won't just push galaxies apart. It'll tear apart stars, then planets, and eventually it'll rip apart the very atoms that make up matter itself.
Okay, I know that's a pretty heavy thought, so let's bring it back down to Earth. As the saying goes, every new discovery brings us one step closer to understanding what most of the universe is actually made of. You, me, the brilliant scientists working at CERN, we are all part of that incredibly rare 5% of ordinary matter. Think about that. We are the universe experiencing itself, uniquely capable of asking these massive questions and building the tools to actually solve this 95% mystery. The answers are out there, just waiting in the dark. So, I want to leave you with this final thought. You've seen the evidence, you know the stakes. If you had the power to instantly solve just one of these great cosmic mysteries, which one would you choose to uncover first? Would it be the invisible skeleton of dark matter? The accelerating engine of